right. Awesome to be here. Thanks for such a warm intro. Now you've made the expectation this high, bringing you back to the ground. My name is Michael Musandu. I'm the founder and CEO of Lalaland. Before you even ask, we have nothing to do with the movie. I read all the time. We're actually an Amsterdam-based startup that uses neural networks to create synthetic humans. So what you see on the screen right now is not a real person. This is completely computer-generated. So same things like deep fakes and things like that, but I'm going to talk, in fact, of how we make this type of technology. As Thomas has mentioned already, we're already working with some of the largest retailers in Europe, the likes of Zalando, Wehkamp, and over 2 million unique website visitors each week consume our images. We've been featured everywhere from Vogue magazine, Forbes, etc. Now that I have your attention, let's bring everything back to the beginning. So I'm actually originally born in Africa, in Zimbabwe, and raised in South Africa. As you can see here is not my pet elephant, before any of you ask. This is actually just what arrives when you order an Uber in Africa. I've been building tech at a very young age, more looking at low-level expert systems. You know, a lot of entrepreneurship in Africa is spurred from desperation, rather the West, which is inspiration. I was very inspired to learn more, so I moved to the Netherlands, did an undergrad in computer science and a postgrad in AI, where I met my also co-founder, Ugnis Rumza, who is more coming from the fashion industry itself. And together we then decided to join forces to actually make the web a more diverse place by creating Lalaland. And what Lalaland does is solves a huge, massive problem of people feeling underrepresented while shopping online. We've all seen this. A typical product detail page. You see an amazing dress at summer, or for the guys, you always see these models with six-packs, but this is what you're usually seeing. And this is a big shame because there's a lot of missed customer acquisition opportunities because the models you're seeing are only shown in one complexion, one body size, and let's not even talk about the age. This is typically below the 25 and below. So this is leading to three painful outcomes for these brands. So beyond the missed customer acquisition opportunities, because people would like to actually purchase products when they see something that resembles them, there's these high return rates, as high as 44%, and even on apparel, 70% in average on people returning items. So really high return rates. And the third thing is fashion has one dirty little secret. So the returns actually end up in a landfill or incinerator. So they burn it. It's cheaper for them to burn these returns than to actually repackage them. So it's actually screwing up our environment. 2.3 billion tons of waste annually every year is caused by thrown away returns. So the biggest question is why? Why are fashion brands doing this? Why is it that they are seeing all these painful outcomes and still having a process like this? In their defense, the problem is traditional photography. It's too expensive to have hiring venues, models, makeup artists, hairstylists. This is happening about 2 to 8 times collection by collection. It's very fast-paced. So it makes it infeasible for them to shoot all these different models to show on one product item to show different consumer segments. This is why they've been selling more of a dream than a reality. So it's just the process. So what we're trying to do to brands is really encourage them to stop selling this dream and to start selling reality. So the Ebo Brufen has finally arrived, what we call it. So basically, Lalaland uses artificial intelligence, specifically neural networks, which we'll go into, to create these synthetic humans for fashion brands to showcase one product on multiple diverse models. It's really simple. From an input perspective, they're utilizing what they currently have on their product detail pages to list their products. They upload it into our platform, which you'll see. They customize the avatars, as they call them, and then they receive on-model imagery that they can put directly onto e-commerce. It's about instant fashion, so we reduce a process that's typically taking brands, the really fast-paced ones, 6 weeks, and the other traditional ones, maybe 6 to 12 months, to a couple of minutes or seconds. So how does it work? How does it look? This is basically it. So on our platform, consumers can actually configure from different type of identities, different type of complexions, upload their collections, and they receive their web shops that they can put online. It's pretty simple from an input perspective to then an output perspective. So how do we do this? How do you generate all of this diversity wasting nothing but data? Is it magic? Is it witchcraft? No, it's just machine learning. So in particular, Lalaland uses generative adversarial networks, which are two neural networks that compete head-to-head against each other to capture variation within data sets. I would like to use the example of Vincent van Gogh. The Dutchies love it when I never say it well. How do you say it? Gogh. There we go. So the goal is to paint a new painting of Vincent van Gogh in the style of Vincent van Gogh. So not the exact same painting, just in the style. When you see this painting, you yourself should say, yeah, this is Vincent van Gogh. He painted this painting. That's the goal. So these two neural networks, one is called the generator. You see, the generator has one simple task. It never sees any of Vincent van Gogh's paintings at all. All it does is try to generalize and create this Vincent van Gogh painting. Then we have the other neural network, which is called the discriminator. This discriminator is fed with a lot of examples of Vincent van Gogh's actual paintings. And it has one job. All it has to do is guide the generator by telling it whether it can tell whether it's a synthetic painting or it's part of Vincent van Gogh's actual collection. So this process iterates, where this generator is blindly painting, and you can see it starts with a bit of noise. And this discriminator is just looking like a black box and opening, saying, no, this is not it. No, this is not it. And for mathematics, this is just probability distribution. So it's just looking at different functions mathematically. After several iterations, it's highly compute intensive. So about 14 weeks, when we're using like Tesla V100 GPUs, the model algorithm then converges. And at this point, what you then see, the discriminator, which is fed the real examples, looks at the generator, which has generated a new painting that it can't tell. It looks at it and it can't tell from the training set or the test set if this is actually one of Vincent van Gogh's real paintings or not. At this point, the model algorithm has converged. And what you see to the left is actually a synthetic painting of Vincent van Gogh in the same style. So that's how the replication works. So how do we do this for meta-humans? I'm going to show you. So generating meta-humans has the same type of process where you have these two neural networks, one's fed with real examples of different type of data points. So different part of the body is trained on different type of algorithms. From hair, from head, from the body, from the actual hands. It's all converged into one big distribution, what we call the latent space. Over several iterations, what you first see is blobs. So this in our generator example of this first neural network is still creating these blobs. Actually, you can't actually see it forging to be something that looks real. You would think this is maybe just some blurry image. But after some iterations, you start seeing shape being formed. And with this continuous process, which I was showing you from this 14-day process, is what you will end up seeing of these photorealistic avatars that you can control on all different parameters, from the hair, the pose. So we highly allow our brands to actually customize this. So they can change different type of models, complexion, body shape, body size. I'll show you exactly how we also allow brands to do the hyper-personalization. So what we've also done is training different parts means you have a big distribution which you can play with. This distribution means where you're looking at the eye gazing for the eyebrows moving up and down, you can see how this latent space is playing around depending on what parameter or what function you keep on following. Same with the aging. I think a lot of you have used Face app or these face aging apps. They use the same type of technology. So we do the same thing where you can actually turn younger images into older. This is where the future is going. One day you're going to be consuming so much synthetic media that you have no idea whether you're seeing what is real or what is not real. And the next thing is, of course, you can also look into different pose alterations. And with this, it becomes very powerful, because now you can talk about going from a 2D image into more a 3D image, which I'm going to show a great example towards the end. So meta-humans, what are the use cases that you're going to see? So we're already seeing this on-site personalization, so this is on Wehkamp sites, where they allow then their consumers to actually filter, depending on maybe different hairstyles you would like to see, maybe different complexions, body sizes, whatever you would like from a consumer perspective, you can actually filter. This is also coming top of the funnel. So with a lot of remarketing campaigns, what you're also going to see is highly personalized and targeted advertisement that's now looking at, based on the demographics that they think they've profiled, you will see campaigns that are going to look like you or campaigns that are making you click to come back into the web store. Of course, with on-site personalization means as a returning customer, once you select one type of body size, one type of complexion, all the models are going to change towards that. So a lot of this personalization. The next is recommendation engines. This is very interesting. So up to now, all we could do is, with personas, you can identify different consumers and then target them based on this. But what we've actually done is, first, we had a big problem where we were asking brands, what type of models would your consumers like to see? And they had no idea. So when they're shooting, usually, it's more looking from a brand perspective of what their brand values are, etc., which doesn't make sense. If consumers want to see something completely different, you're always going to show the opposite. So what we did is collected consumer insights using some sort of a widget to actually identify what body shape, what hairstyle, and after that, we can then tell the brand that based on our insights, this is what we think your consumers would like to see. And that's what we're doing now. We're actually hosting all of the images that we generate, which means we can monitor through an API and a CDN the clicks. So which means everyone in this room would be on the same shopping site, but you would see different type of models that resemble what you would like to see for you to actually purchase the product and return less. We're still doing this on a whole mission to make the web more diverse, which means we want to have more inclusive models than what you traditionally are seeing. So we get to control a little bit of the beauty standard. The last use case, before I open up for some questions, is the metaverse. There's a lot of buzzword around this, and for me, it seems like a rebranding of AR and VR right now. And no offense to speakers that are going to speak, but we've seen a lot of digital fashion brands doing these use cases where they want to fully have processes. They're creating their samples digitally using Browseware, Clothes 3D. Then they'll use an AI avatar, and then they can actually help find their total addressable market by designing garment with these avatars, or put it directly onto e-commerce without actually manufacturing. So they do these build-to-orders or on-demand manufacturing that they only produce the garment once a consumer has purchased it. But we're now showing you that from 2D to 3D, it means that when you're now creating these 3D avatars in OBJ files, the quality is not there yet, but we're getting there where it's going to be photorealistic and not looking very CGI with very low computation. So the future is bright, and that's exactly where we're going to be headed. So please join our mission to make the web a more diverse and inclusive place. Thank you. Cool. I see the signal for time. Are there any questions?
Yes, many. And we have a tool for that. These
awesome.
are randomly generated questions using
Very
GANs.
organized.
No, these are from real people. And I must say, quality is very high. I mean, Liam Tanis, he gets an extra beer during the borrel. He asks, how does the AI know that it didn't generate a real person?
Interesting. Yeah, this is a very
the first time you've been asked this question, or you've already been asked this?
No, I've heard this before. So it's like when you came to our office.
I know.
So for the sake of his sanity, he was like, this looks just real. How do I know it's not generated an actual person that looks alike? But then I took him closer to the images, and I showed him that if you look closely, there are still some mistakes, if you do remember.
Yes.
So some things with, what were the top mistakes?
Earrings.
Yeah.
Very hard to do. Teeth,
Yeah.
sometimes.
And also with the ear, muzzle, and the hair. So I'm finally happy enough that the quality is good enough. If you saw our first version of avatars we were creating, you would have been like, that's disgusting. Is this even a person? So I'm really happy that the quality is good enough now. But at the point to answer the question of how does the AI know if it's generates something real or not? So in this distribution of what it generates, it creates like one DNA. Think of it like this. Based on this DNA, you can still hyper-personalize different parts of it. So you can take like the hairstyle from being a black person's hairstyle to being more Caucasian on the same avatar, on the same DNA. So with this type of personalization, you can actually make your own unique person, right? So for the AI, it's not about it copying what's in the database. It's literally about it knowing and understanding the distribution of that database. So it's just pixels. What we see is pixels, and that makes a person, but for it doesn't even know it's generating a person. The same technology is used for cats, dogs, whatever the case is. It's just pixels and probability distribution.
Awesome. Another question, Richard says, you know what? I am a fashion photographer.
Nice.
Why are you eating my cake?
Interesting question.
Het was eigenlijk kaas van boterham eten, maar you get the gist. Yeah.
Yeah, so we're not yet to take jobs away from anyone from content production. There's that fear of if you're going to automate this whole traditional process, what happens to real models, photographers, people offering venues, makeup artists, hairstylists? There's so much, there's too much disruption too quickly. We still see the solution very complementary. So we're not able, for instance, to do video at this stage, and obviously when tech gets better, you will be able to do so, but you still need some models with social influence. So now none of our models can actually drive traffic towards websites. You still need Gigi Hadid, Kendall Jenner to wear a product so us consumers can go onto that web store. So as soon as you see Gigi Hadid wearing a Tommy Hilfiger shirt, I should be inclined that I want to shop with this brand, let me go into it. And that's where we begin. So when you're on the web store, we're actually just helping support the purchase decision. It's like you're already attracted to shop here. So at this point, it's like we just have to support your purchase decision. Or the dream selling, the aspiration, it's over. We have to make sure that you know what type of product you're going to buy because it's harming the brand's business and also for yourself. So it's very complementary. We're not at the stage yet, and we won't be, where we're the ones that we need to drive social traffic because none of our models have social influence. So at this point, it's a complementary solution that we're still going to need real models and campaign images. All of the top of the funnel advertisement is still going to be muchly driven by real people.
Awesome. Well, so many more questions, but time is up. So, Michael, thank you so much for being part
Thank
of
you very much.
Dutch Digital Day. Well done.